All right, guys, welcome back to the dungeon. Yeah, it's time. We're going to go ahead and start off with our reviews. I'm planning on making as many of these as I can a week. It's probably going to end up being between 2 and 3. We're going to start off with Unit 1, data analysis, and what I want you to do is look through these learning targets in here and refresh on the ones that you need, and you can skip over the ones that you don't. Yeah, so I'm going to go through this as fast as I can, and hopefully this will jog your memory and you'll be able to see all this stuff one more time before you take the exam. Let's do it. All right, moving on here. Okay, number 1, identify the individuals and the variables in a set of data. So let's look at a study here. You want to see the effects of sunlight and varied volumes of water on multiple different brands of carrots. You'll be raising them from seed and measuring the mass of the carrot at the end of the growing season. Interesting. So there's a lot of, we have to know the individuals being studied. Remember, individuals could be people, they could be things, they could be, they don't have to be humans, right? Just the individuals being studied. So let's go and let's make sure we have my marker selected here. Classic Slagle move. Shows up to class without a pencil. What a goon, that guy. All right, so what are the individuals being studied? Individuals. Okay. The individuals are the things that are that we are taking measurements from, if that makes sense. The things that we are taking measurements from are the carrots. So the carrots are the individual things being studied. You could also say the brands of carrots as well. But brand is actually a variable. So I'm going to say the carrots are the things from which we are collecting information. Okay, and remember there are two kinds of variables. Variables are something that we can change. We're studying the carrots. The variables are the things that we can change and the things that we are measuring. So in this case, we can change different things, and then that will affect what we're measuring. and really, this is more in the two types of data. But remember, there was the explanatory variable. Explanatory. I'm going to make it like an EA. Classic. Yeah. Okay. The explanatory variable is the one that we can change, and the response is the one that we are measuring in the end. Okay. Response is the one that we are measuring when we're done. So the individuals being studied are the carrots. The explanatory variables, well, we have a couple. We can change the amount of sunlight, so we are kind of in charge of the explanatory variables. We can change the amount of sunlight, we can change the varied volumes of water, and we can change the brand of carrots that we're studying. So explanatory variables here would be water, or rather the amount of water. We also have the amount of sunlight. We can vary the amount of sunlight and the brand of carrot that we're studying. Okay, so we can change those things, and hopefully in the end we're measuring the response variable, which is the mass of the carrot. Okay, so explanatory, the things we're controlling. Response is what we're measuring when we're done. And the individuals being studied are the carrots. Fantastic. First learning target down. Classify variables as categorical or quantitative. Well, let's think about from the last study. What were the things that were categorical? Why? I should have paid more attention in 3rd grade. Categorical things are qualitative. What are the things that are non-numerical that we can measure? Well, we can measure, let's take a look at what our variables. Our variables are Amount of water, no, that's quantitative. Amount of sunlight, I think that would probably be quantitative. It'd be like the time that they are exposed. So maybe we should put time exposed. Okay. The brand, ooh, yeah. That's what I'm talking about. So categorical would be the brand of carrot. Seed. Okay. Categorical would be the brand of carrot seed, and or categorical, aka qualitative, and the quantitative or numerical, quantitative. Numerical would be, I think, all the rest of them. The amount of water, that can be measured numerically. Time exposed to sunlight, absolutely. And the mass of the carrot is probably in grams. So I would say the H2O, the sunlight, the amount of sunlight or time exposed, and then what was the last one? The mass. These are all quantitative variables. So being able to distinguish which are the things that are non-numerical, basically. Learning target number 2. Make and interpret bar graphs for categorical data. Okay, yeah, let's go ahead and get started. So bar graphs are really, it's better if we think about them in a table first. So what streaming service did you watch the most during your school cancellation? Let's take a look. We'll do Hulu first. We're going to make a little table here. We're going to go through and count how many Hulus are there. So we got a total of 4 columns of 5, so there should be 20. So Hulu is 1, 2, 3, 4. Sounds about right for Hulu. Next one is Disney Plus. All right, Disney Plus. 1, 2, 3, 4, 5, 6, 7. You gotta watch the, all 19, whatever they are. How to Train Your Dragons, or what is the most sequels? I don't know. Okay. Netflix. I just watched Cinderella. That's my favorite movie. You got a problem? Yeah, didn't think so. 1, 2, 3, 4, 5, 6. And Prime Video. Grand total of 3. Hey, look at that. That adds up to 20. Fantastic. So how do we make a bar graph? Well, you can base a bar graph off a couple of things. So if this is our, let me back out. Holy smacks, this is getting long. I have to do this in 2 vids. Okay, remember you have frequency. This is the name of our variable here. We have frequency, and we also have relative frequency. And typically when you make a bar graph, it makes the most sense to use relative frequency as our variable. So here's our frequency. That is the number of times that occurred, and the relative frequency. And you can do bar graphs with either, with frequency or relative frequency. Relative frequency is relative to the total number sampled, right? So it's kind of like a percentage. So we know that there were 20, so the relative frequency for Hulu was 4 out of 20. The relative frequency for Disney was 7 out of 20. The relative frequency for Netflix was 6 out of 20. The relative frequency for Prime was 3 out of 20. So that would be out of 10. This would be 0.2. This would be 0.35. This would be 0.3, and this would be 0.15. So we can express them as decimals. Okay, so what we're going to do here is we are going to make a relative frequency bar graph. So for the bar graph over here, man, drawing straight lines is going to be a real pickle on this pad. Let's try that one more time. Straight down. Oh, that was much better. and straight over. Okay, not great. Oh, they all start with a different letter. I'm going to just do that for ease of access here. So with a bar graph, you don't have, bar graphs are typically for categorical data, right? So you don't have a numerical scale on the horizontal axis. And so instead here, I'm just going to put an H for Hulu, a D for Disney, an N for Netflix, and a P for Prime. And typically what you do is you center the bar on the tick mark for each, and usually to show that it's not continuous, you have a gap in between the bars. So I'm going to do my best. I'm going to do my darndest to make that gap very clear. Extend a little bit further, just like so. That's a little nicer. Okay, and our numbers again. Boy, howdy. Let's not do that. Let's go back to the way we had it. All right, so I'm going to go, the highest one is 0.35, so I'm going to go up 4 tick marks, if you guys are cool with that. 1. It's not like you can disagree with me. You're just watching this on YouTube. 0.1, 0.2, 0.3, and 0.4. Now remember, for relative frequency, they all should add up to 1 when you're done. So if they don't, I've made a terrible mistake. So the bar graph for Hulu goes up to 0.2, so I'm going to make a bar. The YouTube videos for you, sound effects are going to cost you. Disney Plus 0.35. Coming up this way and across. Boy, that that is something else right there. And then Netflix was 0.3. Look at that straight line. Wow, I have got a gift. Now this is already kind of inaccurate, as the widths of my bars are different, and really they should all be the same. Maybe a ruler would be a nice thing to have while you're taking your exam. 0.15. All right, so really the width does not matter with a bar graph, only the height. Perfect. And how do we interpret this? We can interpret the bar graph by saying most people made it through their school cancellation using Disney Plus, around 35%. Around 30% used Netflix to stream information as the most common frequent method, and then third would be Hulu with 20% and Prime with 15%. Next one, let's move on. Identify what makes some graphs of categorical data misleading. Okay, so obviously that's misleading because of the width of my bars. Why is this one misleading? Well, you probably have an opinion, but basically this vertical axis doesn't start at 0. So you're not getting a representative. When you actually zoom out on this graph, it probably looks like this. Right? It's probably these super tall bars, and then this massive increase is really just, it's disproportionately represented here because we are so zoomed in. In fact, you could, if you wanted to take it one step further, right, you could, let's zoom our window in on right here. So you have to be careful because some bar graphs can be very misleading based on what's presented. You have to look at the scale, and you want to really think about the increase of the whole picture, not just a segment. Number 5, marginal and joint relative frequencies from a two-way table. Okay, so I guess it's like what percentage so this is the attendance from last week for my different subjects. I had 21 out of 39 engineering students show up. I had 3 out of 10 math of the trade students show up, and I had 7 out of 13 statistics students show up last week. So let's go ahead and look at the marginal and joint relative frequencies. So marginal relative frequency is basically just for one of the categories. So It is like what percentage of the people were present. That's a marginal relative frequency. So to calculate what percentage of the people were present, you're really looking over in the ends of the totals in the chart. So 31 were present out of 62. So the marginal relative frequency, this is the marginal relative frequency for people present, it's 31 out of 62, which is 0.5. Okay, that's marginal relative frequency. You know, I'd like that number to be just like a little bit higher, maybe 50%, maybe a little higher would be good, but given the circumstances, it's not too horrible. I'd like it to be higher though. Okay, that is marginal relative frequency. You could also find the marginal relative frequency. So we'll do one here and one here in blue for, let's do for stats. The marginal relative frequency for stats, it's all in comparison to the total here. So we would go 13. What percentage of my students? So this marginal relative frequency is not talking about attendance. It's talking about what percentage of my students are statistics students. So that is 13 out of 62, which is a number that starts with something. Okay, that is 20%, 2.29.209.209.7. Okay, perfect. That's marginal relative frequency for statistics. So this tells me the percentage of my students that are statistics students. This tells me the percentage of my students that are present. So we're looking at kind of two different variables. One is whether they were present or absent, and one of them is the class that we're in. Marginal relative frequency looks two different directions there. Green, switch to green for joint relative frequency. So for joint relative frequency, the joint relative frequency this is really in probability, this is the intersection, right? A joint is just the intersection. So what percentage, let's say for people for absent people in engineering? Okay, what is the joint relative frequency for absent people in my engineering class? Well, it is the intersection of absent and in engineering. So that's the one. Oh, so pretty. Okay, 18 out of 62. 18 out of 62. Okay, which is 0.29 roughly. So 29% of my students were engineering students and who were absent. So I think of my total students that I'm seeing. Okay, so that's the joint relative frequency and marginal relative frequency. And I think we didn't really touch on this until probability, but they have a name now, and now you know where to access this. If you see this on the AP exam, just pull up the notes from the Unit 1 review, and you'll be able to know which one's which pretty fast. Okay, moving on. Now let's calculate the conditional relative frequency. We've also done this. This is like with a given. So this is like find the relative frequency. This is conditional relative frequency. Oh, find the the probability. It's kind of probability. Let's not say it from the probability standpoint. Let's find the I don't want to say percentage equal either. That's fine. Probability is fine, I guess. How did I phrase it last time? Marginal relative frequency. Okay, I'll just say marginal relative frequency. How about that? Or conditional. Find the conditional relative frequency for being present given you are in math for the trades. Okay, find the conditional relative frequency for being present given that you're in math for the trades. Okay, so if you're in math for the trades, we're talking about given that you're in math for the trades. So that would be, in this case, given, okay, you're present given you're in math for the trades. That means what goes on the bottom, either 10 or 31. Well, present is the thing we're measuring. Given goes on the bottom out of 10. So this is 3 out of 10, or 0.3. So given that you're in math for trades, basically 30% of the people were present. That's what it's asking. So that's looking out of a single column or row. Okay, you could also do the conditional relative frequency if I had said, it would be phrased differently. It would say, what's the conditional relative frequency for people that are in math for the trades given that they were present? That would be 3 out of 31. So that's something different. Okay, let's keep cruising. Use bar graphs to compare distribution of categorical data. All right, so we've got our categorical data here. We're going to make a segmented bar chart with this categorical data, and I'm going to switch back to, I'm going to just go to black here. All right, a segmented bar chart. So what we're going to do for a segmented bar chart, we're going to come down like this for a two-way table, and we have my three classes. My three classes are engineering, and then I've got my trades math, and I've got stats. Okay, so how a segmented bar chart works is you're looking at the table. I'm going to make this 1 and this 0.5, I guess. Does that make sense? That's all right. We're going to roll with it. Let's go back to the table, and we're going to focus on engineering first. So basically, we're showing the relative frequencies for present and absent. Now, if you wanted to find relative frequencies here, you can. You just divide every single number in the table by 62. So you'd have to do 21 divided by 62, blah, 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 blah. The columns and rows should still add up, and they should all add up to 1 in either direction. Okay, use bar graphs to a segmented bar chart, rather, whatever, bar chart, bar graph. Present versus absent. So what I'm going to do is I'm going to do present actually on the bottom. That makes a little more sense to me as a percentage. and then we're going to graph it here. So present, and I'm going to do all the present percentages first, and then all of the, and we did learn about segmented bar charts, but just briefly, we maybe did a couple. Yeah, so I'm going to switch colors here. I'm going to make blue present. So if we're talking about people that are present 21 out of, let's look out of the total 39 here. So we'll say out of the 39, I'm going to do so 21 divided by 39 is like 53. I'm going to round up. It's like 0.54. So 50, actually I'm not going to put it on here because it looks like it's the relative frequency for the whole thing. So 54% of the people in engineering showed up. So I'm going to draw my segmented bar chart. That's going to go up to like right there and then come across. So that's for engineering. Let's look at math of the trades. That was 30%. We're really doing the conditional relative frequency here. So 30% showed up. So that's 25. 30 is probably right about there. Okay, and then for stats, 7 out of 13. Man, it's exactly the same. 7 out of 13 is 53.8%. So that's going to come up to right here as well. Now my overall attendance rate was 50%. So then what we're doing with the other columns is those are showing the relative frequency of people that did not show up. So this is showing my absent. So we had less than 50% of people absent. Here we had a little bit more here and a little bit more here. I think you'll find that if you go back and do 18 divided by 39, you're going to get whatever this is, and that's going to be equal to 6 divided by 13, and this one's going to be slightly different. So you typically want to have some sort of a key here. So the red represents relative frequency of absent, and the blue represents relative frequency of present. I like the present on the bottom because it shows who's there, and then the absence, naturally we would measure who's there, and then the absence is what we don't measure, which is kind of on top. That's a segmented bar chart for those that don't remember that one. Okay, let's see. Describe the nature of association between two categorical variables. Describe the nature of the association between two categorical variables. Okay, so I think this is like, let's take a look at something like, well, let's see. I think what it's saying here is basically like, is there association? Do you see that, like, for example, students that, if it's a class that is full of maybe students that are more advanced, that are doing more techie or technical material, that is, you're having a higher attendance rate. So is there an association between the class and these? Is there an association between the relative frequency, the rate of people present and the class that you're in? I would say so. Yeah, I would say so. Basically, as the technicality of class increases, the association is that more people are likely to show up. There is an association. It doesn't mean that that causes that. It just says that there is a pattern potentially. These classes are maybe a little more technical, a little more demanding. You have a higher rate, and that probably has to do with the nature of the people that are in the class. If you're drawn to more challenging things, you're probably there because you want to be there. Yep, I would say that present and absent, yeah, those are both categorical. That's exactly what it's saying. Okay, make and interpret dot plots, stem plots, histograms of quantitative data. Oh boy. I think you guys can do a dot plot. You can probably skip this one. I'm just going to do it really, really fast. And if you want to watch it, you can. If you're just like tuning in. You know what would be a great way for you to watch these videos? Just cook your family some dinner, throw it on your phone while you're cooking, chopping vegetables, and you're seeing, that's what I like to do. I like to watch my stats videos while I'm cooking. I'll sit and put on old Sal Khan and let his sultry voice kind of guide my chopping of the carrots. Okay, so it looks like our high here, this is the limbo fail height from class. Our high here is 44, and our low is 32. Okay, so that is quite a few. I'm going to go by twos, and I'll put 32 down here. We'll see how this goes. 34, 36, 32, 34, 36, 38, 40, 42, 44, and then we come and do some dots. We have one at 44, another one at 42, 42, 38, 38, 38, 38, 35. So you're just placing a dot over. You want to keep the first dots all in line so they're not being shifted. 35, 37, 32. Who is that? I think Luke did really well on this one. 36. Owen was the surprise. Showed up late with his instrument. Walked in and just started limboing like a madman. 38, 42 again. 35 again, just right here. 35 again. Ooh. 44 again. That was probably me. Oh, getting a phone call. Yellow. 38. Hello? It is. Hey, Wyatt, what's going on? 41. Yeah, what's the verdict? 37. That's okay. I can take it. Arm and a leg. What's your definition? Like actual arm and a leg? 1. For all, it's for $400 for all 4 of them. Oh, yeah, that's out the window. Sorry. Yeah. Uh-huh. Okay, well I could always maybe trim them down or something too. Okay, I can just come by and check those out. You guys have them on site. Okay, cool, Wyatt. I'll try and do that. That sounds like a good option. Oh, okay. That sounds good. All right. Thank you so much. I'll drop by when I get a chance. All right. We'll talk to you later. All right. Bye. All right. So basically, with the stem and the leaf here, we did the dot plot now. Stem and leaf is a little bit. So notice that for stem and leaf here, we have like 3s and 4s in the tens place. So the key, if this is my key for the stem and the leaf plot, I'm going to call this, let's say 2 and then 8 would represent a 28-inch fail height for the limbo. Okay, 28-inch fail height. So coming up here, we are probably going to have to segment this out. So you can do 3 low, 3 high, 4 low, and 4 high is one way that you can do this for the stem and leaf plot. Notice that you can also compare variables with stem and leaf. If I were to put another line over here, so 3 low is 0 up to 0 up to 4, and then 5 through 9 are going to be in the high point. So let's go through and put our data in. 4 low. Do we have any that are in 4 high even? We don't have any that are in 4 high. That's pretty rough. For a stem and leaf, I would say this is not the plot you'd want to use here. Let's go ahead and make it. Anyways, it's going to look like let's go through the numbers, I guess. 4 low is going to be 44. We have a 4. We have a 2. They do not have to be in order, but they can. 3 high, we have an 8, an 8, and an 8, and another 8. Trying to keep the columns. You want the numbers to be lined up perfectly here. And then we have a 5, a 7, a 2, a 6, an 8, a 2 for 42, a 35 again, a 35 again, 44, 38, 41, 37, 35, and 35. So that's what the distribution looks like. It looks like it's centered on 3 high. Let's go back and take a look at this. Does this also seem to be centered on 3 high? Yeah. I would not recommend a stem and leaf plot for this data set necessarily. Some people, you'll see it used for, you typically want, when you're trying to show the shape of a distribution, you typically want between, like, I don't know, 5 and 6, 5 and 7 little columns, or 4 and 7. You want to see the columns kind of spreading out as such. And we're going to see that a little bit better with, I think, a histogram. So this is a stem and leaf plot with 3 high, 3 low. You put your key at the bottom. Remember that that you are comparing, let's say we were comparing limbo fail height to your actual height, you can put a line here and have numbers extending off in the other direction. These do not have to be in order because it's just showing how many are in that range. It might be helpful for data processing though. Okay, that's a stem and leaf. Histogram time. Again, you want between 5 and, so our low is 32, 5 and, or sorry, between 4 and 6 columns, or 4 and 7 columns typically. So we'll just pick, we're going to go try and do 5. We're going from 32 up to 44 is the highest for our limbo fail height. So that's going to, oh, that was nice. That's going to determine how wide our bucket size is. Okay, bucket size. So 32 and 44, that is a length of, what is that? 12. So let's put 32 at the bottom. And let's do 6 buckets, 32, so that would be 12 divided by 2, so 32, 34, 30, 32 and 34 to 36, 36 to 38, 38 to 40, 40 to 42, 1, 2, 3, 4, 5, 2 to 44. I guess this is actually 7 buckets, and we'll see why in just a second. 46. That's fine. Take a look at the distribution. How many fell in between 32 and 34? Now remember, if something falls on the line, here, then it falls to the right. So how many were in 32 to 34 for our histogram? And oh, sorry, we need a vertical axis as well. So we'll come down this direction. Now we can do a frequency histogram, or we can do a relative frequency histogram. So it's up to you guys, and we can kind of do both. So for frequency, let's just do frequency at first. So we'll do frequency. Let's do our columns here. So I'm going to write the number in between 32 to 34. So that's 32 and 33. I think there was only one. 34 to 36. So we'll cross that off. 34 to 36. That's 1, 2, 3, 4, 5. 36 is not included in that interval. So we've got 5 in between here. 36 or 37. We have 1, 2, 3 in this. 38 and 39. 1, 2, 3, 4, 5, 6. 40 and 41. Just 1. 42, 43, 2, 44 is 3. So those are our options. What we had a total of 21, so that should add up to 21. 6, 12, 15. Sorry. Yeah, that's right. 15 plus, 6, 12, 15 plus 6 is 21. Perfect. All right, nice. So let's go ahead and put our frequency over here. We went up to 6 total. So 1, 2, 3, 4, 5, 6. Okay, and then let's go ahead and put our bars. Now remember, with a histogram, the bars are not separated. They should be coming up and out. So we're going to come up. So this is frequency. We are not doing relative frequency here. Okay, we're going to come up and over for this bar. For 5, that's right there. Sometimes it's better to just draw the vertical ones first. Up to 5 and over. 36 is 3, or maybe just draw the horizontal one like that. Bingo. 6 is at the very top. Isn't that special? Look at that. Okay, 40 to 42 is 1. 42 to 44 is 2. And 44 to 46 is 3. All right, nice. We got our histogram shape here. Does that really jive with what we've seen before? I think so. I think that this looks particularly, actually, this kind of shows the shape of the overall curve quite well. This might be zoomed in a little too much, and we start to think, oh, it might be bimodal or something, but I don't know, this kind of looks like it's got 1 hump. This kind of looks like it has 2, and this kind of looks like it has 2, but this could be normally distributed. It's hard to tell. Okay, identify the shape of a distribution from a graph. So, so basically, you know what I'm going to do real fast is, if you wanted to turn this into a relative frequency histogram quickly, how do we do that? So I'm going to make a little column over here for relative frequency. You just go through and you divide each of these numbers by 21. Okay, so we can check that out. 21, that's going to be 21 divided by, I'm sorry. So yeah, that'll do the trick. So this would be 0.05 roughly. 2 is going to be 2 divided by 21. These are nasty decimals, and so it might be even easier just to keep them as fractions, 1 out of 21, 2 out of 21, so on and so forth. This is roughly 0.1, roughly, almost, and then 3 out of 21, 0.14, and you might want to be more detailed and not round when you're doing this, but the process continues. All right, let's keep cruising, shall we? Identify the shape of a distribution from a graph. Sure. There's a couple things you can talk about shape. The first is, you can talk about gaps. If you see like a bunch of data like this, and then there's like a stretch, and then a little bump at the end, that would be a gap for a dot plot. You can talk about these things as clusters. I wouldn't think this would really, if it's just one data point over here, I don't know if that would really constitute as a cluster, but clusters, and then this is our gap that we have in our data. That's some vocabulary you can use to describe shape. You can also describe the number of basically bumps that you have. So if you're talking about something that is something that has one node like this, we call this unimodal. Okay, if you're seeing something that's got maybe 2 like that, this would be bimodal, and they don't have to be disjoint. So like, I'm going to redraw that. Like, they could look like, right? It could be that they're kind of overlapping and crossing over just a little bit. So this is bimodal, and if you have more than that, you call it multimodal. I don't think that's going to really come up as a problem, but bimodal, trimodal, you can do whatever you want. Okay, there. And then there's the shape. It can be, you've got your normal shape, which is, no, I didn't do a great job. It's kind of a little steeper at the top and drops off. Still not great. Man, it's a lot easier on a whiteboard. Okay, that looks all right. So here's, you got kind of your normal shape. This is symmetric. Okay, if something is symmetric, it means that its median and its mean are the same in the center. Also means that either side, basically the probabilities are the same, but there's also the problem when you have something that is skewed. So if you have something like this and then it kind of tails off, so this is heavily right skewed. It's not super heavy. That's right skewed, and left skewed looks like, okay, this is left skewed. Okay, so you got your shape with symmetry, right skewed, left skewed. You can also talk about some other general shapes. We learned about the normal shape. We learned about light tails versus heavy tails. And then you also have, like, heavy tailed would be like a T distribution. So like a T's, you have it's kind of shallower here, and then it comes out in the tails. So that is also a possibility. Of normal, you have T. You also have uniform shape. So there are distributions that look like this. An example of that was like rolling a 6-sided die. What numbers, the relative frequency that you saw of the numbers? Well, all of the sides are equally likely of being selected, right? So if this is like 1, 2, 3, 4, 5, 6, and you're making a bunch of bars, you would expect the rolls of a 6-sided die to follow a uniform distribution. So you have lots of shapes. You can say uniform, you can say normal, you can say T, you can mention the number of bumps. You can mention gaps, clusters. You can mention right skewed, left skewed. All of that works. Okay, so describe the overall pattern of a distribution and identify any major departures from the pattern. When you see describe a distribution, the acronym that should pop into your head is shape, outliers, center, variability. Okay, shape, outliers, center, shape, outliers, center, and variability. Okay, here's my advice to you on the AP exam. If it says describe, you need to mention all of these in your description. My other advice is if it says compare two distributions and it's got graphs right next to each other, you should probably talk about the shape. You should talk about whether or not outliers are present. You need to talk about the center of either distribution and the variability. Now, what do we have for shape? Well, we have the vocab that we just learned. Outliers, we're going to go over that in just a minute to determine whether or not those are present. On the center, we have lots of options. We can talk about the mean. We can talk about the median. Those are the typical ones that we'll use. And for variability, we have things like the range. We have the standard deviation. And the IQR, or interquartile range. So you can mention all of these as potentials. Standard deviation, variance, pretty much. Okay, let's keep cruising. Compare distributions of quantitative data using dot plots, stemplots, and histograms. I forgot to copy in an image here. You know what? We're going to do that a little bit later. We're going to compare two distributions at the very end, so we'll be good. Calculate measures of center for quantitative data. Calculating measures of center, okay? So for the mean, here, you're just adding up. You do the sum, remember this notation, the sum of all of the x sub i's, okay? And then we are going to divide by the number of our sample size to figure out what x bar is. So if we do that, we end up getting, I'll let you guys kind of, pretty sure everyone knows how to do that. Add them all up, divide by the number of things that they are. I'll let you, but then just remember that notation, the sum of the x sub i's. I don't know if I actually have that mean present here. It's somewhere. I don't have it. Look at me in all my glory. Well, actually, we need to know what it is, so let's just do it really fast. It won't take too long. Oh, you know what? I think I can just copy and paste that into this thing. Make sure I do it correctly.
Hi, Logan. Are you in a meeting?
Yeah, I am filming a video.
What?
I'm filming a video.
Oh, great.
Hi, Oscar.
Hi.
Okay, here's the data. Limbo fail height. Let's take a look at our mean. Oh, our graph looks so good. Okay, our mean here is, if you add these all up and divide, remember, I wouldn't be doing this by hand if I were you on the exam. I would actually really recommend that you're allowed to use, devices, and you're allowed to use notes. I would really recommend that you have this website, stemplots. You can go to, quick way to do that is calculate one quantitative variable. Maybe copy the data. I have it in a list here in Excel. I can click, highlight the data, copy, paste. You may even be able to do this straight off the AP exam. Copy it, just press paste into the data, press begin analysis. It gives you everything that you need there. So our mean is 38.19, our standard deviation is 3.43. Our minimum is, there is no reason, I think, why you need to do this by hand. I don't think that is going to be something that you're going to see on this shortened exam. And we have that summary statistics there for us, and we're going to be using that to verify that we got it. So 38.19 is our mean. That's what we're going to be looking for, and what we're going to be using for the rest of this. Calculate the measures of center for, other measure of center is the median. So how do you find the median? You're going to order all of the data. That's going to look like, so this is the mean. Okay, let's do the median. All right, the median is going to be, we're going to order all of our numbers from low to high. That's going to be 32. Well, yeah. What does that look like? 32. You have a function on your calculator that can sort. Another thing that you can do here if you have Google Docs open, it's really handy. There is a sort range on your TI that is available. You can also select, I'm going to shuffle the range up, right? These are the same numbers for the limbo fail height. I'm going to scroll down and copy, and then right click, and you can sort and then choose from low to high, and it'll automatically put them in ascending order. The reason that is helpful is we know that there are 21 options. Since there are an odd number of limbo fail heights, you're going to count to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then this one should be the 11th, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the center number is 38 here. You can order them on paper. I would not recommend that. I would recommend them plugging it. You can do it on paper if you want. Plug them into a list. If it's asking you to show your work, you should, but plug them into a list on your calculator to calculate the median, or just generate one variable statistics to calculate the median if it's asking for that. So on your calculator, I think if you need a refresher on that, let me know. I'm happy to show you in class. So your median is 38. Let's double check with our summary statistics and see if that popped up. Yeah, median is 38, so we've got that correctly. If there is an even number of numbers in the list, then you take the average of the middle two. So let's say there were 20 observations, then you would go to the middle two and take the average. Okay. Let's keep going. So that's the measures of center, means and medians. Fantastic. Mode, most often value is also 38, it would seem. So the median and the mode are the same. All right, calculate and interpret. Do we have to interpret the last ones? No. Calculate and interpret our measures of variability. We're almost done here, folks. Calculate and interpret our measures of variability. Range, standard deviation, IQR for distribution of quantitative data. All right, so let's do the range first. The range is as simple as the min minus the max, so that's pretty straightforward. I think you guys are probably comfortable with that at this point. Range is max minus the min. Said that backwards. Okay, the max is 44 minus the minimum, which is 32, which is 16. Yeah, sorry, 16. Good Lord, Slagle. It is 12. Whew, the range got me. Look at that. Okay, the range is 12, so how do we interpret the range? Interpret the range is our data varies from, varies at most by 12, which would be from 32 to 44. So it's how our data varies. Our data varies by at most 12 from 32 to 44. All right, let's go ahead on to the next one, the standard deviation. Standard deviation, the equation for that is S, the sample standard deviation, is equal to the square root of the sum of all the xi's minus x bar squared divided by n minus 1. Okay, so let's see if we can do this by hand to show how you would do this in your lists. It's a little rougher, but you're going to get this from one of our statistics anyways. So I'll just do it real quickly in the list so you can see where that comes from. So here's all my x sub i's. The first thing that happens if we're looking at order of operations here, the last thing is the square root, and we're going to square root the sum divided by n minus 1. So the first thing that we do is we take all of our observations, our x sub i's, and we're going to subtract the mean x bar, which we know to be 38.19. And then we're going to take those values and we're going to square them, and we're going to add them all up. So let's go do that. So take all our x sub i's, so I'm going to say equals. So in your calculator you would do, if this is list 1, you would do in here L1 or L2 equals, right? So we're going to do equals, and you would click L1, and then you can do minus 38 point, what was it? Look at our one variable, 38.19. Okay, so that should be below the mean, and I'm going to click and drag that all the way down. All you'd have to do on yours is you would say L2 equals L1 minus 38.19, and you can do this in multiple steps if you'd like. Yeah, so this is L1 minus 38.19. Okay, and then we're going to take all of those variables and we're going to square them. So this is L2. This is L3, which would be L2, list 2, if this is list 2. Okay, and this is going to be this squared, list 2, and I'll just say squared. So, and you can do that all in one step if you want. Equals this box raised to the second power. So we're squaring the difference. You'll notice as it gets closer to the mean of 38, the difference squared is much smaller. Okay, and then what we're going to do here is we are going to sum all of the squares up, the difference between the mean. So I'm going to put a total box down here. You can find sum in your catalog of your calculator. You go to your catalog and go press S, it'll go down to sum, and then you're going to say sum of list 3, because list 3 is where all your squares are. And then you're going to take that, I'll do equals sum on here, and click and drag 235. So then now let's calculate the standard deviation, which is going to be equal to this. Let's do the square root, which is the 1/2 power. So I'm going to do this divided by n minus 1 divided by 20. I don't know why I have that in bracket there. Oh yeah, I do. Because I'm going to raise this whole thing to the 0.5 square root. 3.4295. So we'll say 3.43. Now let's take a look at the summary statistics. Oh gosh. 3.43. Look at that. We got it. We did it by hand, or we did it using a calculator. Obviously, this is not the method that I would use to do on the exam. You use one variable statistics, but it's helpful to know where it comes from. Nice little review. Yeah, so we get a, I'm not going to, doing this by hand is atrocious, so you get 3.43 for, and what are the units? The range, this is in inches, we have a range, so we observed values from blah, 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 blah. The standard deviation is, the interpretation of this is basically on average, we can expect our observations to vary by about 3.43 inches from the mean of 38.19 inches. So basically, if a new person walked into the room and did their limbo test, we could expect their observation to fall usually. They would usually fall around between either side 3.43 from the mean of 38. We can expect it to be around there. Okay. Move. Oh, IQR. Crap. IQR. Let's go back to that sorted list that I had for, yeah, where is that? Excuse me. We're going to go back to the sorted list that I had for this. We can get rid of, so we know our middle value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's our middle value. I'm going to color that gray. And then we need to find Q1 and Q3, we look at the lower half of the data and the upper half of the data when finding that. And since we have an odd number here, you just look at what is remaining, I believe, to find Q1 and Q3 for those quartiles. So we're going to look here, and there is for we took one out. Actually, I'm gonna verify that. This is the same thing that I was kind of had forgot when we were doing this before. I'm gonna verify that. Okay. Yeah, so that would be n plus 1 is 22. Okay, so it's saying 22. That would be just a sec. 0.25. Yeah. Okay. So for this one, you are not including the median in your in calculation of quartile 1 and quartile 3, right? So like for here, there are 10 observations. So we go to 1, 2, 3, 4, 5, and then halfway in between 35 and 35 is 35. So to calculate quartile 3, we're actually taking the average of these two. And to calculate quartile 1, sorry, quartile 1 is the lower side. And to calculate quartile 3, you're taking the average 1, 2, 3, 4, 5, taking the average of these two. So that's going to be the calculation for quartile 3. That's going to be the calculation for quartile 1. And then our quartile 2 is our median. So we should be getting 35 for quartile 1 and 41.5 for quartile 3. Let's double check. 35 and 41.5. Look at that. Okay. That's what I figured it was, but I wanted to double check. Okay, so we've got quartile 1, quartile 3. So finding the interquartile range now is you going to do Q3 minus Q1. Basically, the interquartile range holds the middle 50% of the data. So quartile 3 is 41.5 and quartile 1 is 35, which will be a total of 6.5. That makes sense. Okay. So what's the interpretation of the quartile range? Basically, the middle 50% of our data exists from 35 to 41.5. I should say in the middle of our data, we should say of our class's limbo fail heights. We want this in context. Perfect. All right, cool. Explain how outliers and skewness affect the measures of center and measures of variability. Sure. Let's go through those really fast. So, measures of center and measures of variability. We're going to talk about basically first of all the mean. The mean is very sensitive to outliers, and the median, or Q2, is very resistant to outliers. So, for example, if we're looking at this data set and we added one more value for the mean, let's take a look at that. I'm going to go back to here and copy the data, and we're going to go back, do single group. I'm going to copy it in, and I'm going to put a space, and I'm going to add a lower, let's say someone was really good and we had like the world record holder there, and he came in and did it in 16, he had failed at 16 inches for his limbo fail height. Let's look at our analysis now. All right, so the mean, let's go even lower. Let's say someone did 6 inches. Or rather, I can't go very far in that direction, so let's actually go up on the high end. I know this is not as interesting if we're not a world record holder, but let's say someone failed at 100 inches and they really sucked. Okay, so begin analysis. Okay, is that in there? Yeah, begin. There's our obvious outlier, right? The mean is 41. The median is now 38. So the mean changed by almost 3, or the mean changed by 3 roughly. The median, which was our median was, I forget, median was 38. Well, guess what? Our median is still 38, even with that outlier. So the median doesn't necessarily, is typically much more resistant to outliers. That's what you need to know. So we'll call this more of a robust statistic in this term. Okay, so in this sense. So is the mean is sensitive, would be the word I would use, to outliers. The median is resistant. Resistant. Okay, let's talk about the measures of center, the measures of variability. The range can be greatly affected. This is sensitive. So sensitive. Okay, this is sensitive to outliers, meaning an outlier will have a great effect on the range because you're talking about the max and the min, right? Standard deviation is also sensitive to outliers. How did the standard deviation change? Our previous one was 3.43, and our new standard deviation is 13.596. So it went up an unbelievable amount, right? The standard deviation is huge because it's basically the average of the deviations, essentially the average of the deviations from the mean. And so we had this one that creates this outlier for deviations. Okay, let's look at Q3 and Q1. Well, now Q3 is 42, Q1 is still 35, which means our IQR did not change hardly at all. So the range is sensitive, standard deviation is sensitive, the IQR is resistant. So if you are trying to choose statistics to use when you have an outlier, you want to use the IQR and you want to use the median. It's not saying these are bad. It's just saying these are kind of bad when there's an outlier. And when you have, one thing that's really important here is when you have data that is skewed like this, in this case, the median is over here. So here's maybe Q2. The mean gets pulled to the right. So the mean ends up being higher than the median when the data is skewed to the right. It pulls the mean to the right. And similarly, when your data is skewed to the left, the mean gets pulled to the left, and the median kind of stays roughly at the center of the data. Okay, so this is the middle point, and then the X bar is kind of like the balance point, I think is what they said, because you're having this effect of leverage that's pulling the mean over, the balance point over. Finding outliers, we've kind of gone over this before, I think, but basically you just do the boundary for an outlier is 1.5 times the IQR plus Q3. So if it's 1.5 times the IQR plus Q3, that's an outlier, and 1.5 times the IQR. I should either say Q1 minus 1.5 times the IQR. Kind of got it flipped backwards there. That's all right. So we'll go ahead and plug this baby in. The IQR is 6.5. So we're going to do 1.5 times 6.5 times Q3, or plus Q3, which is 41.5. Okay, so let's do that real fast. The cutoff boundary, this is not in your summary statistics, so this is something that you might be likely to calculate. 9.75 plus 41.5 is 51.25. Okay, so if you have anything that is bigger than 51.25, you've got an outlier, which we don't, so that's fine. Okay, and then down here, Q1, I think was 35. All right, so we do 35 minus 1.5 times 6.5 RIQR. $25.25. If you have anything lower than 25.25, you've got an outlier, which we don't, so we're in good shape. All right, make and interpret box plots of quantitative data. We're going to do that here. So for a box plot, you draw your horizontal line. Can be vertical, can be horizontal. We're going to go from, let's say, from 30, 32, 34, 36. Okay, so basically how we make a box plot is you're going to draw a vertical line. I typically start with, you can start with the min, the max if you want. The min is 32, so you draw a vertical line right here at 32. Your max is 44, which is right here. So that's showing the range of our data. Gotta love these box plots. And then you typically want to get to the median first. So actually, with a modified box, so this is a regular box plot. Regular box plot, min and max are always these lines. If it's a modified box plot, which is what you're likely to see on the IP exam, this line isn't necessarily the minimum. It's the minimum that isn't an outlier. So if you had an outlier present, you would see a star over here, and then the second lowest value would be what would appear as the left side of the bar. So if it's a modified box plot, those stars are represented and then you have the data continuing from there. Sorry, I'm just gonna forget about there we go. All right, and our median, our middle value is 38. So there's our middle value. So you put a vertical line at 38. Q3 is 41.5. So there's 41. I'm going to go over just a smidge and then complete the right side of my box. And then Q3 is 30, or Q1 is 35, which is right there. Complete this side of my box and the dots. That's how you do a box plot. Okay, yeah, and if you have an outlier, that's not included. So if we had that 100 or whatever, it's not included in the graph. And so let's actually see that. You can do that on this website as well. So you have your dot plot, you have your histogram, and you can change the widths there. You can do a box plot. So you have typically it will ignore that 100 that we added in, and then just show everything else that's over here. Okay, last slide. This has been a long one, guys. Yeah. The last learning target is use box plots and numerical summaries to compare distributions of quantitative data. So let's go ahead and do SOC V for both of these so we can practice doing that. All right, so how would I start? I would mention shape. So it's hard to say whether something is, perfectly symmetric just based on the sample. I would say that the wingspan, so this is comparing our class height and our class wingspan, the wingspan appears roughly symmetric. So let's say the height is just ever so slightly skewed to the left. But that's okay. So the wingspan is, talk about shape, roughly symmetric. Roughly symmetric, and is, I'll say, and the height is very slightly left skewed. The reason I can tell it's slightly left skewed is that this gap, this right 50%, and this this section is the left side is wider. Okay, this is slightly wider, but it's not as noticeable as in the top. The height is very slightly left skewed, and both are unimodal. There's our shape, outliers. There are no apparent outliers in either data set. Center. Let's see, what is a good measure here? I think it makes more sense based on the box plots. You can use means. So you could say it this way. Although the means are very close to the same, comma, the median for the heights was 69 inches, which is 1 greater than the median for wingspan at 68 inches. Pulling that from the median data here. So we've done shape, center, and we've done shape, outliers, center, and now what's left is variability. wingspan seems more variable than height. Now, one thing I want to note here, guys, when you're talking, you can't just end there. The AP exam does not like it when you just say is more variable than height. Why? I know it's painstaking, but you have to actually reference the numbers that you are using. So basically, I think the easiest way for us to do this is we can talk about all three measures, really. The standard deviation is larger, the IQR is larger, and the range is larger. So you need to mention those things. As the standard deviation, the range, and the IQR are all larger. And you could even put measurements in there and say like at, so the standard deviation is 4.368, comma, the range 78 minus 59.5. Oh. 18.5. And the IQR 71. Someone went really specific there. Minus 65. 6.65. Respectively. Okay. And I think what would a whereas would be nice here. So you say the wingspan seems more variable than the height, as the standard deviation, the range, and the IQR are all larger at 4.3 inches, 18.5 inches, 6.65 inches, respectively, whereas heights were, say heights measures, scrolling down, were 3.672 inches, comma, what is that? Oh, I guess that's like 10.3 wide. Yeah, 10.3 and oh no, that's yeah, that's right. What did I just do? Range, standard deviation. What's the order? Standard deviation, the range for wings, or the range for height is not, that's not correct. It's 75 minus 60.7. 14.3. 14.3. That should be 14. And the IQR, and you get it from here, I'm sure, but. And the IQR is 71 minus 65.85. 5.15. I would just say, I shouldn't say is there, it's just 5.15, and then respectively. All right, that's it in all its glory. It's a long video. Again, I'm not expecting you guys to watch this whole thing every single time. That would be absurd. Skip through the things that you need to see, or you can just read your book to save some time as well. It's up to you. But thank you for tuning in. If there's anything that you missed, feel free to bring it up in class time. Class time, I'm planning on basically just going over AP questions and hopefully doing at least 2 of these reviews a week, hopefully more. Okay, guys, thanks for tuning in. We'll see you next time.